Welcome to the structural analysis course. So up to last module, we have discussed the different types of failure theories. So in this lecture onwards, we'll start new module of our structural analysis course, that is the deflection in a beam. So how can you calculate the deflections in a beam after application of loads? So this is very much important aspect for for a structure, because after application of the load we have to understand how much structure buckles, right? If you have a, if you just let's assume a simply supported beam. I hope you know what is simply supported means. Simply supported means one end is hinge, another end is roller. Now if you apply a load into a beam, what will happen after application of the load? Your beam will buckle, right? There will be deformation, there will be the deflection in the beam. So we have to find it out, or before only we have to identify how much deflection will take place after application of load. So we have to understand very precisely how much deflection will be taking place, because if you design a building and after application of load, maybe so many people came at the top of the building. So after application of the load, if the slab of the building deflects too much, then what will happen? All the person will feel panic, right? And anytime the slab may collapse. If the deflection is more, then anytime the slab may collapse also. So to get the idea how much deflection will takes place in a beam or in a slab, it is very much important for us to analyze and design a structure. So in this lesson, or basically in this module, we'll discuss the different methods, how exactly you can find it out, the deflection and the deformation in a beam after application of loads. So before going into the actual calculation part or actual determination of loads, let's review a few more things. Like already we know, right, how many supports are there. So in our structural analysis, we have three types of support. First one is fixed support. Second one we have is hinge support. Hinge, or we call it pin support. Both are same support. And third category of support we have, that is roller support. Right? So in our structure, or in general, if you see in any day-to-day life, we normally encounter with three types of support. What are these three support? First one is fixed. Fixed means what? Fixed means if you consider a joint, just let me draw here. So fixed means if just consider a cantilever beam, means this is a wall and a beam is connected here, right? And this side is you have wall. So this beam is actually embedded into a wall. So now what will happen? Now if you pull this bar, pull this beam by gripping in this location, and if you pull this beam, what will happen? This joint, so this joint is basically a fixed joint. So this joint won't come into this direction because here it is fixed, right? This joint won't move into horizontal direction. Similarly, now if you apply a vertical force here, what will happen? So this joint won't go up as well because this is a fixed joint. So this joint won't move in this direction. This direction also won't happen. Similarly, if you try to rotate this joint, so this portion won't be rotating because this is a fixed joint. So fixed joints means it has three reactions. Very much important. You have to understand this very clearly. So fixed joint means it has three reactions. So if I call you, if this joint is a fixed joint, means this joint cannot move to this direction, this joint cannot move to vertical up direction, and this joint cannot rotate also. So everything is prohibited in this joint. Then we call it, this joint is a fixed joint. Then what is a hinge joint or pin joint? So hinge joint or pin joint means if this joint is a hinge joint, then you cannot move this joint into this horizontal direction. You cannot move this joint into this vertical direction, but you can rotate this joint. Rotation is allowed, but this to translation is not allowed. So can you give me example of hinge joint? So basically hinge joint will get it in many places, like in our door is also a hinge joint, like in our laptop, right? In our laptop, that monitor and the keyboard. has a hinge joint. So in many places you will find hinge joint. Hinge joint means the joint to translation is prohibited. Like this joint cannot move into horizontal direction, cannot move into vertical direction. If this is two are not allowed, but this joint can rotate. So that is our this second joint, hinge joint. And last joint is roller joint. What is roller joint? Roller joint means that joint it cannot move vertically. Vertically it cannot move, but it can go to horizontally. And moment also allowed, rotation also allowed. Okay, so in many places you will find hinge joint, roller joint, like in a window, if you see the sliding window. So sliding window is a good example of roller joint, right? Because the window can move into the horizontal direction. In a sliding window case, the window can move into the horizontal direction, but window cannot move into the vertical direction, right? So that's why we call it is a roller support. So very much important, you have to understand we have the three supports. One is fixed support. Fixed support means normal, if you see in the beam column joint in a structure wherever you are sitting, that beam column joint is basically a fixed joint. Similarly, hinge joint means the door is connected through hinge into the wall, right? That we call it hinge joint or pin joint, both are same. And then lastly we have the roller joint or roller support. Basically we'll see in the sliding door or sliding window you will find the roller support. Okay, so these are the three supports. So once again I'll just recapitulate. So fixed support has three reactions, means fixed joint cannot move up after application of load, cannot move horizontally, or you cannot rotate a fixed joint. So that's why in two-dimensional structure, fixed joint has a three reactions. What are these three? It will have a horizontal reaction, it will have a vertical reaction, and it will have a moment, fixed end moment. Right? Next, you have a hinge joint. Hinge joint means here the joint, it cannot move into the horizontal direction, it cannot move into the vertical direction, but it can rotate. Rotation is allowed in a hinge joint. That's why the reaction in the hinge joint, you have the two unknown reactions, that is reaction with the horizontal reaction and the vertical reaction, but the moment, joint moment in a pin joint is actually zero, unlike fixed joint. Fixed joint has a moment, some value it will be there, but whereas hinge joint there is no moment. And last one is roller means the restriction is given only in the not restriction, the movement is allowed in the horizontal direction, whereas vertical and the movement is restricted in a roller support. So that's what three supports. So let's first discuss after application of load how supports will behave, right? So this support is what? This is a roller support, this third category of support. See, the symbol is roller is there, and then you have the support. So whenever you see this type of symbol, that we actually denote roller support, right? So roller support means, so now if you apply a load into this beam, if you apply a load here, maybe a point load you have applied, so what will happen? The beam will deflect. So this is a deflected shape. This shape is basically deflected shape. So beam will deflect. So as I mentioned, the roller support means it will have only one reaction, vertical reaction. Means this joint cannot move vertically. So you will have a restraint in the vertical direction, the joint. Whereas this joint can move easily in the horizontal direction. Horizontal direction, the joint can easily rotate or easily move basically. Right? This is a roller. What about the moment? So moment also zero in the roller support, right? We discussed. So in roller support only you have the one unknown reaction, that is the vertical unknown reaction, whereas moment is zero as well as the horizontal reaction also zero. So as moment is zero, that's why the slope of this curvature, this line curvature will start at this point itself, right? So after application of the load, this is the buckle shape, right? Buckle shape. So after application of the load, the beam will buckle in this shape. Okay, and at the joint also you will have some slope because there is no moment. there is no moment, reaction moment at the support. It is zero, right? Because it is a hinge support. Sorry, it is a roller support. So this is the deflected shape of a roller support. Now if you see pin support also has how many reactions? As we discussed here, pin support or hinge support also has two reactions. One is vertical and another is horizontal. Right? These two reactions will be there. Whereas moment is zero. So there is no resisting moment in a resisting moment in a pin support. So that's why whenever we apply a load into a beam and which is supported, pin supported, then this is a deflected shape. This blue color line is a deflected shape, and you will have a slope at the joint, right? So just I'll one more important concept I want to just explain here. So just consider it. This is a beam, right? One end is hinge and another hand is roller. So roller means we have two wheels at the bottom and then this is a roller. Now if you apply a load here at the point load P you have applied, now what will happen? So this beam will deflect in this shape, right? So this part we call it deflection of beam. So how much it is deflected, that is the deflection. And one more thing is slope. Slope means what? If you draw a tangent, this tangent how much angle it is making with the horizontal, that we call it slope. So whenever you apply any load into a structure, it will have two unknowns basically. One is the deflection, means how much deflection takes place from the original beam, and then you have how much slope at different points. So in this point, what will be the slope? So draw a tangent, and this tangent how much angle it is making with horizontal, that is we call it slope, right? So what we discussed here till now we discussed is if you have a roller support, then the slope at this point is not zero because moment is zero. That's why the slope at this point is not zero. So you have a theta slope after you apply the load. Similarly, if you have the pin jointed structure or pin jointed support, then here also slope is not zero because here moment is zero, moment reaction moment is zero. So slope is not zero here. You will have some theta. So now this is the third category. That is if your joint is a fixed joint, right? That is here if I written fixed first category, that is shown here. The fixed category means the deflection means this point won't move in any of the direction, right? This point cannot move horizontally. This point cannot move vertically, or this point cannot rotate also. Means you have a fixed end moment. So that's why slope, if you see slope at this point, theta is actually zero because the deflection will not start at the joint. It will start after some time. See, here it is straight line. The deflection started after some time it started because it is a fixed joint. But here if you see pin joint, deflection started even from the support itself. Here also if you see roller, deflection started at the support itself because here the reaction moment at these two support is zero, right? Whereas fixed end reaction moment is not zero. You have three unknown here: horizontal reaction, vertical reaction, and moment. Right? So slope and deflection, and at this point, slope theta is zero, whereas deflection also zero. Whereas if you see pin support, the slope is not zero. Slope you have some theta at the support. Whereas deflection at this point is zero. Deflection means this point won't move up or down any direction after application of load. Similarly, this is also roller, that you have the deflection because moment is zero. Deflection you will get some theta at the support, whereas the deflection at this point is also zero. So delta we call it deflection, capital delta this is, okay, and this theta is we call it slope. So these three we discussed. Now if you see a frame structure, okay, so if it is a frame structure like two members are connected through pin joint, if it is pin joint, what will happen? Pin joint, as we discussed, pin joint, the slope will be there. I mean the deflection will start even from the support itself. So this blue line is a deflected line, right? So deflected line will be always starting from the support itself. That's why you will have a slope also at the support. The support you have slope theta. But if these two members are connected through fixed joint means what? Basically you have welded this joint. If you consider this is a steel bar and this is a steel bar, if you weld it through welding, both the joint, both the bar, if you connect through welding, then we call it this is a fixed joint. Whereas if you, if that both the bar you connect it through a pin, then we call it the pin joint. So this is a pin joint. Whereas if you connect it through welded connection, then we call it is a fixed joint. So in this fixed joint means the deflection won't start from this, after a little bit deflection will start. So this is a fixed connection. So this is an example. If you see, this is a veranda. The two member frame support both the dead load of the roof and the live load, that is live snow loading. So this is a girder, or this is a beam, which is actually this end is embedded into the wall, whereas this end is simply supported to this column, right? And this beam is taken care the load of the slab, as well as if any snowfall is happening during the winter time, then that snow load also will be taken care by this beam, right? So this frame, so this is a frame structure. So this frame can be considered pin at the wall side. So this side you can consider it as a pin joint, right? And this side is basically grounded, right? This is a fixed grounded here, and this joint is basically welded connection, right? So this is also a fixed connection. So this joint is also welded, means fixed connection is there, right? So that's how we make our original structure into analytical models. These are the analytical models, and we do our structure analysis. So in this lecture, we'll see how exactly you can draw a deflection curve. We won't derive anything in this lesson. We will draw the deflection curve. What is deflection curve? Deflection curve means after application of the load, how the beam will deflect. That we call it deflected shape or deflection curve, right? Let's see. So this is a beam. This is a simply supported beam, right? Simply supported means this end is hinge support, whereas this end is roller support. And two forces are acting into this beam. One force is P1 acting downward, whereas you have another force P2 acting upward. So two forces are acting. So after application of this load, can anyone tell me what will be the deflected shape? So deflected shape, you can tell that because see here the force is acting upward, right? So this portion of the beam will go up, right? And then here the force is acting downward. So this part will bend downward, right? So this may be the deflected shape. So this line may be the deflected shape. So easily by just inspection, we can draw the deflected shape of a beam. So in a beam, the deflection in a beam member normally takes place because of the bending moment in a bar. So after application of the load, the bending moment will develop inside the beam, right? As we discussed, or maybe already you have started in your first year course, basic course in structures. There you know how to calculate the bending moment and shear force, right? So after application of the load, basically bending moment will be developed inside the body or inside the member. So this, because of this bending moment, the beam will now deflect. So this is the moment diagram of this beam. This is a moment diagram. So you can see here the negative moment will be generated because this is upside, right? And here you have the positive moments. So where the bending moment changes its sign, we call it this point. We call it point of contraflexion, or we call it inflection point. And this is a deflected shape. Just now we have drawn, right? This green color line is a deflected shape. After application of the load, the beam will bend in this fashion. So this is a deflected shape. So here you have a positive moment, right? Positive moment, and here you have negative moment. So this is a deflected shape. So this is our sign convention, right? If moment is acting in this direction, like this direction is acting, so beam will be bending concave upward, right? This concave upward means we call it is a positive moment, whereas if it is a concave downward, this portion will be concave downward, so we call it is a negative bending moment. So that's why you say it is negative, and here it is mentioned positive. Now similarly, can you draw the bending the deflected shape of this beam. So here also this is a cantilever beam. One end is fixed, another end is free, and two forces are acting. One is P1 and P2, both are concentrated force. So what will be the deflected shape? Draw the bending moment first. So bending moment diagram will be in this fashion. And this is a deflected shape. The deflected shape will be what? So after application of this is a fixed end, right? Fixed end means the deflection won't start at this point. It will go fixed little bit, and then because of this P1 deflection will start, right? And then P2 will be there. So this is a deflected shape of this beam. So after application of P1 and P2, the beam will deflect in this fashion. So this is exactly the deflected shape. You will see this is a fixed end support, right? This is a cantilever means fixed end support. So here actually slope is 0. So curvature not started just from support. Curvature started after if you go some time, then only curvature started, right? So that's why this is the deflected shape after application of P1 and P2. So just by inspection only we can draw the deflected shape of any beam. Let's see few more examples also. Now this is also another, this is we call it propped cantilever. So one side is fixed, another side is roller. So and then if you apply a load P, then what will happen? So this is a deflected shape. Please note that this is a fixed support, right? That's why deflection won't be starting from the joint. It will be from the joint. It will be little bit straight because here you have the moment, right? Here you have the fixed and reaction moment. So the deflection won't start here. It will start little bit going there. Then deflection will start because of this load P. This is a deflected shape. Whereas at A it is a roller support. So that's why deflection even from A also you will find slope is not 0. You will have some slope here. Whereas here slope is 0. Similarly, if you draw deflected shape of this beam, so here only a concentrated moment is acting at this point. So because of this moment, this beam will deflect in this manner because this is a roller support. That's why here you have the slope, negative slope. Here you have the positive slope. Again, here also it will go up, right? This is a deflected shape of this beam. Similarly, this bar, if you see, this is also a propped cantilever. One side is fixed, another side is roller, and here you have an internal hinge. Means one more hinge joint is there at B. So once we apply a load P, what will happen? So it is a fixed joint, right? So deflection won't start from here. It will go a little bit, and then deflection will start, and it will go like that. So you have B is a hinge joint. So that's why you have more deflection happening. So now if you see this beam, this is a fixed beam, right? This end is a hinge, this end is fixed end, this is also fixed end, and the UDL is acting. So deflected shape will be, deflection won't start from the support because it is a fixed support, so it will go a little bit, then deflection will start. Again, this end is also a fixed end, so it will, so little bit straight will be there, and then deflection will be happening. Because fixed end has a reaction, right? Fixed end has a reaction force, support reaction. Because of the support reaction, the slope or the deflection at this point is 0. Same thing happening here also. You have a load here, and this is a deflected shape. Similarly, if you have a UDL at the middle, so this will be deflected shape, will go something like that. So now by just inspection only any beam, we can draw the deflected shape, right? But our main objective is what? Our main objective is obviously to draw the deflected shape plus how much deflection happened. That also you have to find it out, right? How much deflection takes place here after application of the load UDL W, how much deflection takes place, that we have to find it out. That is our objective. And another objective is how much slope happening at the different point. For example, if you draw here a tangent, then how much angle it is making, this theta, that is also unknown. So our objective will be to find out delta. Delta is basically deflection, and we have to find it out theta. So theta, right? What is theta? Theta is the slope at any point in a beam. Thank you so much. So in the next class, we'll discuss how exactly you can compute the deflection and the slope of a beam.